Today's lesson is on comparing linear and nonlinear functions. As we remember, a linear function is a function that has a specific constant rate of change and follows a pattern, and we can graph them using y equals mx plus b. A nonlinear function then is a function that does not have that constant rate of change. So these are not going to create straight lines. So if we were looking at number 1 here, and we want to determine, is this a linear function or not? I have to see, does it have a constant rate of change? So when you're looking at your x values, is it changing at a constant rate? So plus 3, plus 3, plus 3, and you're looking at your y values. This is minus 8, minus 8, minus 8. Yes, it does. So when we want to define, is this linear or nonlinear, our justification is that as x increases by 3, y decreases by negative 8. Okay, and it is a constant. The rate of change is constant. Therefore, it's linear. That's what those 3 dots mean. So looking at number 2, 1 to 3 is a plus 2. 3 to 5, that's plus 2. 5 to 7, plus 2. So your x's is constant. Take a look at the y's. 2 to 11, plus 9. 11 to 33, well, that's plus 22. 33 to 88, that's plus 55. So as x increases by 2, y increases by different amounts. Therefore, this is considered nonlinear. If you would graph this, it would not create that straight line. I mean, think about it. If your first order pair is 1, 2, and then you're going to 3, 11, and then 5 to 33, I mean, as the one is only increasing by increments of 2, the other's increasing by changing increments. So it's going to escalate pretty quickly. So this is going to create a nonlinear function. At this point, you can pause this video and you can see numbers 3 and 4. So number 3, you're going to see that as x increases by 7, y decreases by 5. So it is linear. And the last one, number 4, although y decreases by 4 each time, x increases by different amounts. So your rate of change is not constant, and this one is nonlinear. So linear versus nonlinear. We can look at it as the table. Does it have that constant rate of change? Or you can look at it as a graph. Does the graph represent a linear or nonlinear, and why? Well, it's pretty obvious in number 5. It's not a straight line, so it's not a linear function. So this one here is nonlinear because it's not a straight line. The next one is linear. Each time x increases, y is remaining the same. So it's creating that straight line. X is increasing, y stays the same, so it's a constant rate of change. This last one is nonlinear. I-N-E-A-R, there it is. Because even though, like in this one, your x values are increasing, then they're decreasing, as are your, I said that wrong, your y values are increasing and then they're decreasing. So even though your x values are constant, they're going up, your y values are going up and then back down. So it's nonlinear. You can also see it doesn't create a straight line. So we can look at it in an equation format as well. A linear function, just like we learned in our last lesson, is that an equation can be that linear function if it's written in that form of y equals mx plus b. So in order to determine, you have to actually change it to that form. So like in number 8, I'd have to put this into y equals mx plus b. It's quite simple in this one. You just subtract 3 from both sides, and you're going to have y equals 2x minus 3. Yes, that's in the slope-intercept form. So therefore, this one is linear because it's in slope and intercept form. This next one, as you look at here, it looks like it's almost in slope-intercept, but in actuality, This is not your slope times x. This is a value divided by x. So this is actually what's called inverse variation. It's not direct variation, it's called inverse variation. But this can't be written in slope-intercept, so this one is considered nonlinear. Now this next one looks a little tricky, but if you just simplify it, so by subtracting 2 pi x from both sides, so 2 pi x from that side, you rewrite it, it's going to be 3y equals negative 2 pi x plus 12, divide by 3, and you're going to see it is y equals negative 2/3 pi x plus 4. So this is actually in slope-intercept form. Pi is considered a value. It's just a representation of a value. So this right here is your slope. It is a true value, negative 2/3 times pi. So this actually does create a linear function. That one messes kids up quite a bit. The last piece here is like, you can look at something of compound interest versus simple interest. This is like when you go to a bank and you have a credit card, or you borrow money. Sometimes they charge you something called a simple interest, or sometimes they charge you something called compound interest. What compound interest is that you have to pay interest on this money borrowed, and it compounds. So if your balance, like simple interest, if your balance is $100 in year 0, then the next year it's 110, then it's 120, then it's 130. It's gaining $10 each year. So if you look at account B, it starts at $100. Year 1, it gains 110, so same as the other. But year 2, it gains 121, so it actually earned an extra $1. Year 3, it gained 133.10, so it earned an extra $3.10. That's because your interest rate, your APR, is being calculated to the balance, to that 121, not just the 100 it initially was. So then to calculate the next one, you're gonna multiply your balance by whatever your interest rate is. So each time it's getting more and more and more. So as you graph this, you will notice that account A has a positive increasing slope. Both of them actually have a positive increasing slope, but account A is linear. So account A is going to kind of go like this, and it's going to be linear, but account B is going to follow the same track. I'll do it in a different color. So account B is going to follow the same track, but slowly it's going to escalate a little higher. So that one's considered nonlinear, since the constant rate is not the same each time. There is no constant rate of change. So account A, linear; account B, nonlinear, because your constant rate is not consistent. So a linear function can be written in that form of y equals mx plus b. You can also see it in a table if your x is changing consistently and your y is changing consistently. If the rate of change is the same, then it's linear. You can also look at it as a graph, and if it creates a straight line, it's linear. If it does not create a straight line, if it's curved, it's nonlinear. If you cannot write it as y equals mx plus b, it is nonlinear. If your rate of change is different, like in these up here, it is nonlinear if something is not changing by the same amount. So linear versus nonlinear.